Welcome to this Concept Explainer, brought to you by CBSE ScoreLab of ProfSam.com. Today we are undertaking a crucial deep dive into Unit 8, Electromagnetic Waves. We promise to make this concept so simple, so exam-safe, that you will finally understand how light, electricity, and magnetism are all, well, unified in one beautiful phenomenon. So let's just jump right in. Think about a simple question. You are sitting in a room right now, and maybe your phone or radio is playing some music.
Okay, yeah.
That signal travels from a tower, maybe miles away. It passes through thick concrete walls, and still it reaches you.
Right.
But now think about visible light. Light is also a wave, right? If you switch off the lights in the next room, the wall blocks it completely, instantly.
Yes, of course.
So how is it possible? How can one kind of signal pass right through a solid wall while another, like light, is just stopped?
Yes, that is genuinely confusing.
If sound waves need air, how can these phone signals travel through empty space and even through walls? They seem to follow totally different rules. Exactly. And here's where it gets really interesting. What if I tell you that the invisible radio waves passing through your walls and the visible light bouncing off your screen are actually made of the exact same thing?
It's same thing. How?
They're both electromagnetic waves. The only difference is how fast they wiggle or their oscillation frequency. Let's unpack how one phenomena does so many different things. The entire unit, really, it all revolves around one core idea, a zero-level concept. Electric fields and magnetic fields are not separate. They are two inseparable aspects of one single electromagnetic force.
So they were studied separately before?
Yes, for a long time. But Faraday showed that a changing magnetic field, it generates an electric field.
Right, electromagnetic induction.
Precisely. Then Maxwell realized for nature to be symmetric, for it to be consistent, and to explain how light even exists, a changing electric field must also generate a magnetic field. It's back and forth. The engine, let's use an analogy. Think of it like two dancers in sync. One dancer is the electric field, E. The other is the magnetic field, B. And they are sort of dancing together, but always perpendicular to each other. So whenever the E dancer moves, it automatically pulls the B dancer along. And when the B dancer moves, it pushes the E dancer.
Yeah, so they keep each other going.
They keep each other going. They oscillate in perfect sync, creating this traveling wave pattern.
Yeah.
That pattern, that is the electromagnetic wave itself.
It sustains itself.
That analogy helps with the motion. But
Yeah.
what keeps the wave stable? Why doesn't it just, fall apart?
That's an excellent question. The stability comes from its structure. Let's build a mental image for this. Imagine a vast, dark, calm ocean. That's empty space, vacuum.
Okay.
Now a buoy starts bobbing up and down. That's our oscillating charge. It creates a vertical wave.
No.
That's the oscillating electric
Up,
field.
up and down. Got it.
But that up and down motion also creates a swirl in the water side to side. That's the oscillating magnetic field.
Ah, so one causes the other? Exactly. And the most important part is this. The up-down E field, the side-to-side B field, and the direction the whole disturbance travels forward are all mutually perpendicular, like the X, Y, and Z axes.
So the fields are creating each other, and that's why the wave doesn't stop or need air to move.
Precisely. That mutual creation, that self-sustainment is the key. But to fully understand this, we need to look at the missing link Maxwell discovered, the displacement current. Now let us see how NSERT formally defines this concept. This is the term Maxwell introduced to solve a huge paradox.
Can I read the definition from the text?
Please do.
The displacement current is given by the expression ID equals epsilon, not d phi E by dt, and is due to a changing electric field acting as a source of a magnetic field in exactly the same way as conduction current.
Perfect. That definition is everything.
Yeah.
Let's break down why we even need this ID using the capacitor paradox. It's a very important exam topic.
Okay.
So Ampere's original law was simple. It said magnetic fields are only produced by conduction currents, the actual flow of electrons in a wire. IC.
Okay, that makes sense. Current in a wire makes a magnetic field.
Right. But what about a capacitor that's charging? Current, IC, flows to the plates. So there's a B field around the wires. No problem. But between the capacitor plates, there's a gap, an insulator. No charge is flowing across it. So IC is zero.
So Ampere's law would say the magnetic field in the gap must be zero.
Exactly. But that creates a contradiction. The magnetic field can't just appear and disappear. It has to be continuous.
Okay. That's the paradox.
That is the paradox. And this is Maxwell's genius. He realized even though charge isn't flowing, the electric field between the plates is changing rapidly. This changing electric flux, d phi E by dt, he said,
Yeah.
must act like a current. It must create a magnetic field.
So it's not a real current, but it has the same effect?
It's an effective current. We call it the displacement current, ID. And when you add it to the law, you get the complete Ampere-Maxwell law. The total current is I, C plus ID. The magnetic field is continuous everywhere. The paradox is solved. Hope everything is clear so far. This concept explainer is from ProfSam.com. That is ProfSam.com. Okay, so once Maxwell fixed this, once we had the generation mechanism, the properties of the wave become very clear. There are three non-negotiable properties for your exam. First, as we said, is perpendicularity. E, B, and the direction of propagation are all mutually perpendicular, always.
Like the XYZ axis.
Perfect. Second, the fixed speed. In vacuum, every single EM wave, I don't care if it's radio or gamma, travels at the constant speed of light. C equals 3 into 10 to the power of 8 meters per second. And third, the fixed amplitude ratio. The strength of the fields are related. The electric field amplitude, E naught, is always C times the magnetic field amplitude, B naught. E naught equals C times B naught.
Wait, if the E field amplitude is always so much larger, like 300 million times larger, why is the magnetic field even important? Does it really contribute much to the wave's energy?
That is a brilliant question. And many students get confused here. They confuse magnitude with importance. The truth is, the electric field and the magnetic field contribute equally to the energy of the wave.
Equally. But how?
Because the energy density formulas are different. When you calculate it, the electric energy density and magnetic energy density are exactly the same. The B field is absolutely essential. It's the partner that keeps the dance going. Now, let's just do a very quick example to connect all this. Say a radio station broadcasts at 100 megahertz. What's its wavelength?
Okay.
We use the universal wave equation, C equals F times lambda. We know F is 100 megahertz, which is 10 to the power of 8 hertz. And we know C.
So lambda would be C divided by F?
Exactly. So 3 into 10 to the power is 8 divided by 10 to the power of 8.
Oh, it's just 3.3 meters.
3 meters. The wave crests are 3 meters apart. This is why it connects back to our first question.
Because a 3-meter wave is so large, it doesn't see the small atoms in a wall. It can just pass through or around them. But visible light, with its tiny nanometer wavelength, just hits the wall and gets blocked. Is that the idea?
That is precisely the idea. The entire electromagnetic spectrum, radio, microwave, infrared, visible, UV, X-ray, gamma, they're all the same thing. The only difference is their wavelength and frequency.
And that difference explains all their different behaviors.
All of them. Penetration, energy, everything. And you see, this chapter perfectly connects electricity, magnetism, and now optics. The idea that light speed changes in a medium is the whole basis for refraction, which is our next chapter. Okay, now let us focus on what we call the silent killers. These are the common traps and misconceptions that cost students marks. Trap number 1, the medium trap. The wrong idea is that EM waves need a medium, like sound needs air. Students think this because they learn about mechanical waves first.
Right, like waves on a string or in water. So what's the correct way to remember it?
The key is the EM waves are fastest in vacuum. They need no medium. Remember this hook. EM waves are the disturbance, not a disturbance of something. The fields themselves are oscillating.
Okay, so they are the wave, not a wave in something. Got it.
Perfect. Trap number 2, the alignment trap. The wrong idea is that E and B fields are parallel. Students think, well, they are created together, so they must point in the same direction.
Which is wrong.
Completely wrong. The correct idea is that E and B are mutually perpendicular to each other, A and D to the direction of travel. Just remember our hook. E, B, and propagation are like the 3 axes of a coordinate system. And a third one, trap number 3, the energy source trap. A few students think the wave is self-sustaining, so it's creating energy from nothing.
That violates conservation of energy, so the fields are just, what, passing the energy back and forth?
Exactly. The wave is just exchanging energy between the E field and B field as it travels. It's carrying the energy that was originally supplied by the source, the oscillating charge. It's not creating anything new. Now, to make sure this sticks for the exam, let's lock in a couple of memory anchors. First, the physical gesture. Use your right hand, point your fingers in the E direction, let's say up. Now curl them toward the B direction to that side. Your thumb now points in the direction the wave is propagating. Forward. Practice that. It physically encodes the directions.
EBC.
Okay. The second is an extreme association. Imagine a lightning bolt, but freeze it in mid-strike. Instead of just electricity, visualize it as a cascade of invisible E and B fields spiraling outwards at the speed of light. That raw power is an EM wave being released. All right, to finish this deep dive, let's summarize the 3 most critical points you must take into the exam hall. Number 1, the existence of electromagnetic waves comes from Maxwell's displacement current, ID equals epsilon, not dIE by dt. This proved that a changing electric field creates a magnetic field. symmetry.
Right, the missing piece.
Number 2, EM waves are self-sustaining perpendicular oscillations of E and B fields. They carry equal energy in both fields, and they all travel in vacuum at the constant speed of light, c. And number 3, the entire electromagnetic spectrum, from radio to gamma rays, is the same fundamental phenomena. They only differ in frequency and wavelength, and this difference explains all their varied properties. To get maximum marks in 12th CBSE Physics, Chemistry, and Maths, visit ProfSam.com.
That is Prof Sam, right?
Yes, ProfSam.com. Thank you for diving deep with us today. All the very best for your preparation.